So the last lesson in the finance is called a payout annuity. It's kind of like the real deal of it, where like you've done all the work, you're ready to retire. That's kind of the point of an annuity, is to put money away for later. So you're ready to retire, and there's a couple different strategies. So on the first one, I've got this formula for these first two. This formula doesn't work on the bottom two. We got a new formula that we'll put on the sheet. But they introduce a new letter that we're not used to, which is D. D is regular withdrawals. And again, I have the same typo right here where that should be a 4 instead of a 3, so we'll fix that real quick. But what regular withdrawals is this. After retiring, Carl wants to take $1,000 every month for a total of 20 years into his retirement account. It earns 6% interest. So this $1,000 is what he wants to like withdraw from his account. By the way, withdraw means take out of. Right? So you put all this money into your account, you would like to take some money out, so $1,000 goes right there. I is the same thing as we've been doing all chapter long. It's our interest rate, which as a decimal, 6% is 0.06, divided by 12 because of months. So same old story. Let's punch that guy in. What's 0.06 divided by 12? And then we won't round him off, 0.005. And N is the same thing as before, years, time compounding periods. So he wants 20 years, because they said it right here, and they're doing it monthly, which is 240. But the different thing is we have a whole new formula to deal with this guy. So we just got to put him in the right spot. The good news is he's an easy one to punch in, you know, if you follow my lead, but I'm going to write him down. He is D, which is 1,000, times 1 minus 1.005. Same story as before where we added that. But check it out. New exponent. He's not to the nth power. He is to the negative nth power. So since n is 240, we're going to go to the negative 240th power. Then we'll close up the parentheses there. Then we will divide that by I, which is 0.005. So this is a straight shooter in the calculator. Just watch your parentheses, put them where I asked you to put them. So let me move this out of the way. We will do 1,000. Please punch with me. Parenthesis 1 minus 1.005 to the negative 240th power. Close that guy up, divided by 0.005. So I punched all that in. And this is how much he needs in the account to retire. So if he wants to take $1,000 out every month for 20 years, we just figured out, bro, you need this much money. Here's what we're going to do on homework. We're going to make it a little easier. We're going to round that to like the nearest whole number. Instead of like 2 decimal places, we're just going to round it to the nearest whole number. So how about 139,581? $139,581. Like, the change really doesn't matter in this situation. Like, yes, you could put 78 cents. That would work. Like, if you type it in homework, it's still going to accept it. But rounding it to the nearest dollar is also going to work. So do you see how I did $81 instead of $80? Does that sound okay? So how much money was pulled out of the account? Put yourself a little help right here. That answer will be D times N. How we figure that out is you got D right here, you got N right here, right? So he wants $1,000 to come out of his account every time, and he wants to do that for 20 years. So every month that would be 240 times. So if we punch that in, 1,000 times 240, boom. He's going to take out $240,000. So let's just see if we can break this down. The first one, nice and slow. Homeboy Carl here is going to take $240,000 out of this account in that 20-year time, right? He did $1,000 240 times, right? So he took that much out. You know how much he put in? Basically $139,000, right? Are you with me on that? All he had to put up front was $139,000. And as the 20 years passed, that money sat in his account and earned interest, right? So he earned all the way up to getting $240,000 with all of that interest. So how do you find the interest? We take that $240,000 and take away that answer right there. So I'm going to do $240,000 minus that number that we got for Part A, 139,581. So he basically made $100,000 and 419 as well. $100,000 plus the 419. So it's like, to make this happen over his entire life of working, you know, you usually work till you're around 60, 65, depending on what kind of career you have. He had to save up basically $140,000. You know what I'm saying? He had to save that up so that way he could retire and then take $1,000 a month away for 20 years and get $240,000 out of that. Right? So he made $100,000 doing that. Let's try another one. That's weird, right? Let's say after retiring, Rick wants to take $2,500 a month out. That's a lot of money, man. $2,500 a month is a lot of money you like to be pulling out of the bank, but still, that's what he wants to do. $2,500 a month. I is that same way we've been finding it all chapter long, so it's our percent divided by, I think all of these are going to be per month. You know, that's usually how people like to roll when they retire. They got their monthly payments, you know, like your bills and all that stuff happen every month, so that's why all these are going to be per month. So we punch that guy in, 0.075 divided by 12. We get that weird decimal. Don't round it, 0.00625. And N is going to be 25 years times 12, because he's going to do it for 25 years every month, right? So times 12. You punch that guy in. 25 times 12. 300 times. So they say, how much will he need to do that? Old boy's going to need some money, right? If you want to take $2,500 a month out for 25 years, you're going to need some money up front, right? You know, it's like you got to have some of that. So we'll use this formula. 2,500 times 1 minus 1.00625 to the negative 300th divided by 0.00625. I'm kind of going fast through that. Let me know if you're not sure where I got those numbers from, but it's a very similar formula to what we've been using all chapter long. Right? Let's punch that guy in. Get your parentheses in the right spot. You should get a large number back. You know, we should get a large number back. So 2,500 parenthesis 1 minus 1.00625. Missed a 6 there. 625 to the negative 300th power. Then close up the parenthesis and divide by that nasty decimal. I like this formula, though, because it's easy to punch in. I think this is easier than last time's formula. Should get a big boy, right? We'll round that to the nearest dollar, and I don't think homework's going to care if you put $299 or $300. You know what I mean? It's going to be close enough in that ballpark. So why do you say we call it the nice one? How about 300 instead of 299? Does that sound okay? So $338,300. That's what this guy Rick needed to save his entire working life to make that happen. So like, let's say he started around 25, because that's around the age people really start thinking about retirement savings. It's like, okay, I'm 25, kind of got my life going where I want it, better start saving some money up, you know. So from 25 to 65, he had to save that much money. Let's see how much money he pulled out. One more time, that's D times N. He did $2,500 times 300. He did that 300 times. That's a lot of times, man. 2,500 times 300. Holy crap, he pulled out $750,000. $750,000. Because when he put his $338,000 in the bank, it sat in there for 25 years. But all he did was take a little bit amount out every month. He took $2,500 away, so he took a little out every time, right? But it was still a big chunk of money in there, earning interest all the time. So how much interest did he earn? This guy minus that guy. 750, minus $338,300 bills, y'all. He made $411,700 just by doing that. So he saved basically $300,000 his whole life to pull out $750,000 when it was all said and done. This is called a payout annuity. Very cool strategy. A lot of people in careers do it as a 401k. I don't know if you've ever heard of that before, you know. They do like Roth IRAs. I am not a financial expert, so I don't know that much about it, but usually when you get your career, they will start putting some money away for you every month for you to start saving. So then maybe you'll have that $338,000 to do something with when you turn 65, you know. So cool. That's different than the next guy. Let's write this formula down. First, in that spot, we'll write it down. So in this formula, they are asking us, it's like, how much can he withdraw? This is more of a realistic style of a question because we know Rick has $600,000 for his retirement because he saved it his whole working life. He's going to earn this much interest when he puts it into this annuity. He wants to make withdrawals for 20 years. They say, like, how much can he pull out? You know, how much money can he do every month? So we don't figure D out ahead of time because that's what they're asking us to find, but I is 0.075 divided by 12, just like it always was. Like, nothing really changes there. And you keep seeing them same numbers, so 0.00625. And N is going to do it for 20 years times 12. 20 years times 12. So figuring those two guys out, it's a simple move right here. S, by the way, if I didn't explain, is like the final amount, right? S is the big number, the future value. That's that 600,000. So upstairs, we're going to have 600,000 times 0.00625. You see those two numbers now. S is the big number, and I, we figured out, is that weird little decimal right there. So we're going to multiply those together. We'll just do it all in the calculator. And then downstairs is 1 minus 1.00625 to the negative 240th. Sorry, I forgot to figure that 240 out, but it's negative 240. You cool with where I got the 240 from? So it's just a weird setup at first. We'll get used to it. When are we doing this? When they ask us how much is the monthly withdrawals going to be. So using parentheses where I have them highlighted here, we will put the first thing in parentheses. So it is 600,000 times 0.00625. Be careful that you didn't hit divide on accident. So I wanted to multiply those together, and I close up the parentheses. Then it is, this big fraction bar is the divide guy. Start your parentheses over for downstairs, and then it's a normal 1 minus 1.00625 to the negative 240th. And then looks like I need to get out of the exponent to close my parenthesis up. So it's just the whole upstairs was in parentheses, divided by the whole downstairs was in parentheses. And let's see if we got the same number, because it's very easy to hit a wrong button, you know, like, did you get this or not? Are we okay with that? Do you want me to punch it in one more time? Cool. How much can he withdraw every month? We will round that to the nearest dollar, right? $4,834. Is that okay? $4,834. Hell yeah, Rick. How would you like to take $4,800 out every month? I'll bet you'd be a happy camper. Rick did his work ahead of time. He saved himself $600,000. So now in his retirement, he's got basically $5,000 a month to mess around with, right? So how much total money was pulled out? That's the same as before, right? That's the same as before. So we're going to take this number. Oh, I guess it's not the same as before. I apologize. This number, 4,834, because he did that every month, right? He pulled that out every month. Do we know how many months he did this for? 240. So that number times 240. Punch that in. 4,834 times 240. Rick took out over $1 million in this time. 1,160,160. Is that the right numbers? I got to double check it. 1,160,160. He started with $600,000, and then because of this payout annuity, he could take out almost $5,000 a month for 20 years. So he actually kind of took out $1 million plus in that scenario. How much money is in interest? This guy minus the starting amount, $600,000 is what he started with. So he earned $560,000 in interest. We'll do one more of those guys, and then we'll talk about the weird scenario. So Dave has $450,000 saved for retirement, so not as much as Rick. He's earning 9% interest, bro. That's amazing. 9% divided by 12. So 0.09 divided by 12. 0.0075. And then N, he wants to just do it for 15 years. So 15 years times 12, because he's doing it every month, right? You know, so he's going to do it every month for 15 years. So 15 times 12. I haven't done that one yet. 180 times. How much can he withdraw? That'll use the formula. Big boy times I. So 450,000 times 0.0075 divided by, in parentheses, 1 minus 1.0075 to the negative 1/80th. And then we'll just punch that in. Let's see if we can get the right number. He shouldn't be making as much money every month as Rick, because Rick had 600 grand to start with, and this guy Dave only had 450 grand to start with. So parenthesis 450, 1, 2, 3 times 0.0075. Close that parenthesis up. Divided by 1 minus 1.0075 to the negative 1/80th. And then I always mess up that parenthesis right there. I need to hit the right arrow on my calculator to close that parenthesis up. If you need help typing that, I'll get you started with it. But, oh boy, we'll round that to the nearest dollar, 45.65. Do we sound okay with that? 45.65? Punch it in one more time if you messed up. Sometimes that happens, you know. Try it another time. I punch it in wrong. Sometimes we miss a 0 in a spot, you know, so punch it in again. But 45.65. How much money did he earn? Every month he pulled out 45.65, and he did that 180 times. Where did that 180 come from? And then we'll punch that in. 45.65 times 180. $821,700 dollar bills. How much was interest? So you take your new big number minus your old big number. 821 something or other minus 450,000. And he made $371,700. Didn't make as much money because he didn't do it for as long. But because the point of this class is to think about real life scenarios, while you get your computer out, can you tell me what's really a big loophole in this system, why it might not work that good? Interest rates, I think they'll be locked in. I like that idea, right? I think they'll be locked in, right? Any other ideas? Go ahead. Say again? Well, obviously, yes. If you don't have the money to put away, it ain't going to work. Assuming all these people have the money to put away, why might they not get it all back? They could withdraw more, right? This won't let it. I like that idea. If you sign up for this, it says, okay, this is what you can draw every month. That's all you're going to get, right? Go ahead. Ooh, yes. If finance goes down the tubes, that's always an issue. That's very possible. Here's the one that we don't think about. Tell me about these people when they start doing this. Are they old? What could happen to them? They could die. You know, the thing on this is like, I'd like to do this for 20 years. Well, I'm pretty sure you're starting at 65. So we're like doing it to 85. Yes, people live to 85, but it's a weird thing that everyone has to come across if they live to be old. It's like, okay, how much money do I need? And how old am I going to be when I die? Because you can't answer that question. You know what I mean? So it's a weird one, right? It's like, I'd like to do this for 20 years. You might live longer than that. You might not live that long. So it's a weird financial scenario to be in. Let's do some homework.